Recording in
All right.
progress.
So we're gonna start section 1.5. This one covers the multiplying rational numbers. So again, nothing new here. This will start us on page 22, right there at the very bottom. And we'll probably move into the next one here very quickly. So in elementary school, you learned that multiplication is repeated addition. So like 4 plus 4 plus 4 plus 4 plus 4 gives us 4, 8, 12, 16, 20. 4 times it's or times 1, 2, 3, 4, 5 is also 20. We've got that here. 1, 2, there's 5 of them. So we have multiplication so that we don't have to add numbers to themselves multiple times. You can just say 4 times 5 is going to give us 20 instead of 4 times 4 times 4 times 4 times 4. So it just simplifies that whole process. As we move into algebra, we use the X symbol for multiplication less, and we begin to use some of the other symbols. So we could say 4, and we use a dot times 5 is 20, and then also we can use parentheses. That's probably the most commonly used one to denote the operation of multiplication. Because as we move into algebra, we have X, which is the operation of multiplication. And then we have italicized X, which is a variable that is representing a number of some kind. And if you're not extremely careful about having a nice straight printed X for multiplication and a more cursive X for the variable, it starts to get very confusing very quickly. So that's why we use the parentheses and the dot. At the top of page 23, you want to make sure that you have your properties of multiplication written down. So I feel like these are not new. We did this quite a bit last year. Same thing as, very, very similar to addition. Commutative property. And work. Commutative property of multiplication, use the asterisk sometimes, just means 3 times 5 give us the same answer as 5 times 3. Both of them are 15. Doesn't matter which order you multiply things in. The associative property. Come on, internet, hang on. Associative property of multiplication means that we have 3 times 5 in parentheses multiplied times 2. Put it up against it. That's the same as 3 times 5 times 2. The first one is 15 times 2, which is 30. The second one matches what we memorize in our multiplication tables. We can do 5 times 2, which is 10. 10 times 3 is 30. So, associative property. The multiplicative identity property is a little bit different. Identity property of multiplication. Now, we have to be careful here. The additive identity property means that any number plus 0 is itself. But what is any number times 0? 0. That's a totally different property in multiplication. So what can we multiply? Thank you. So any number, I'll pick 18, times 1 is just 18. So be careful there. The identity property of multiplication, this is where you have to be really careful. Now we'll start being very specific. If I ask you what property, you need to tell me whether it's the property of addition or the property of multiplication. Identity means any number times 1 is itself. And the inverse or multiplicative inverse property they don't talk about here. Hold on. We'll talk about it later in the book. They probably do. I'm going to talk about it because y'all know it. So the inverse property of multiplication, I'm sure they talk about it at the end. So the inverse property of addition is a number plus what? Its opposite, right? Because with addition, we have to add any number to its opposite sign gives us 0. The inverse property of multiplication says that any number, we'll say 9 over 4, times its multiplicative inverse. What do we call the multiplicative inverse? Do you remember this word? Reciprocal. Awesome. So the reciprocal is the inverse of a number. So any number times its inverse gives us what? Not 0, but what? Right? Because those 9s are going to cancel each other out. The 4s cancel each other out, and we end up with a solution of 1. So the inverse property of multiplication says any number, so this is your number, times its reciprocal or multiplicative inverse. That word's just fun to say. I like it so much. Or its reciprocal equals 1. All right, there's 2 more that we talk about here. Both, again, you should be familiar with. The distributive property, which I always want to spell wrong. Okay, we don't specify the distributive property of multiplication because you only distribute with multiplication. So the distributive property, our example here, if we have 3 times 6 plus 7, that's the same as 3 times 6 plus 3 times 7. If you remember, this is the one when we did it last year, I would like draw an arrow from the 3 to each term inside the parentheses. It's being separated by an addition or subtraction. And then you multiply that times those numbers. All right, so the distributive property is only with multiplication, and you're distributing the exterior term to each term inside. And then we have its inverse. So the inverse of the distributive property is called factoring. This is not in your book, so make sure you have it in your notes. So factoring would tell us that I'm going to do this with a variable. If we have 3, we'll get to that. 3 times, not a variable, keep it a 6. 3 times 6 plus 3 times 7 is the same as 3 times 6 plus 7. Typically use it when we're working with variables. Let me show you. Let's work it out. What's 3 times 6? 18 plus 3 times 7 is 21. Now over here, what would we solve first? On the right side, the 6 plus 7. So this is 3 times 13. So 18 plus 21 gives us 39. 3 times 13 gives us 39. So it's exactly it's the same as the distributive property above, but in reverse order. So the 3 is being multiplied by the sum of 6 plus 7. So that's where that other 3 goes. Instead of multiplying 3 times 6 and then adding it to 3 times 7, we're just adding the 6 and 7 and then multiplying it times 3. Because 3 is the common factor between both of those terms. All right, last one, the zero property, we just discussed it earlier. That means that any number times zero is what? Zero. So if you get some crazy irrational number like the square root of 71, and you multiply that sucker times zero, your answer is zero. Don't have to worry about it, right? The zero property. All right, so since we're still on multiplication, what are the parts of a multiplication problem? There we go. Factor, factor, product. Yes, that one was flipped up. It's always the subtraction and division that are hard. All right, so a product is the answer to a multiplication problem, excuse me. And then a factor is any number that's being multiplied. So factors, just like add-ins in an addition problem, can be positive or negative. So we have to look at the signs to determine if they are, if your answer is going to be negative or positive. So for example, if we have 3 times negative 5, what's the answer to 3 times negative 5? Negative 15. And let's see how that works in addition. So this is negative 5 times itself 3 times. So negative 5, or excuse me, negative 5 added to itself 3 times, plus negative 5, plus negative 5. That's negative 10, and then so it gives us our negative 15. So you can see why if you have one negative in your factors, your answer is negative. So what happens if both factors are negative? It's positive. So let's do 3 times negative 5. That gives us, what, our negative 15? Right? And we know that 2 times negative 5 gives us negative 10. 1 times negative 5 gives us negative 5. And then we're at 0. 0 times negative 5. Okay. And then we get to negative 1. Negative 1 times negative 5. So you'll notice with each of these, we are subtracting 5. So we're subtracting 5 every time. So now that it's negative 1, it becomes a positive 5 because we just, hold on. Subtraction, even though I know it's addition. I'm confusing myself. I apologize. So every time we lower the number of the product, 3, 2, 1, 0, we add 5. So again, we're adding 5 to 0. That gives us a positive 5. If I have negative 2 times negative 5, I'm adding 5 to 5 again, and I end up with 10. So that's why a negative times a negative is positive. All right, we got that? So here's the rule. If, I'm going to put this caveat in here because this is very important. If after simplifying absolute value, you have an even number of negatives. So with negative signs, your answer is always going to be positive. And then the inverse of that is if you have an odd number of negative signs, your answer is going to be negative. Why did I include the absolute value caveat here? What happens if you have a negative number inside absolute value? It's actually, its value is positive. So you have to solve the absolute value, then count your negatives. Let's get a decent example. Oh, you've grown out of sketches. We just do examples. Okay, so if I have, let's get a first example here. -2 times -3 times -5. First off, is my answer going to be negative or positive? Negative. Why? I have 3 negatives. So one negative times another negative gives me a positive, but then that positive times another negative gives me a negative again. That's how that works. The easiest thing to do is just count your negatives after absolute value. So we know our answer is going to be negative. So now we can ignore the signs and just do the math. 2 times 3 times 5 gives me 30. -30. There we go. Then it's just basic multiplication. Counted your negatives, you know how many you had, you're good. Let's look at another option here. Let's see. So 4 times we'll keep it somewhat simple. All right, so what do I have to simplify first here? Got to simplify this guy right here. So this is actually 4 times 3 times -5 times 2. So now how many negatives do we have? Therefore, our answer is going to be negative. So I know that I have a negative, and I can ignore, yeah, 4 times 3 is 12, 5 times 2 is 10, 12 times 10 is 120. And we're done. All right, let's do a quick review of multiplying fractions. Now that we understand, we remember the whole negative positive thing when it comes to multiplying. The rule is the same when you're dividing. You just make sure you always count the negatives in the numerator and the negatives in the denominator. So just a little bit of a review of decimals. When we multiply decimals, do we have to line up the decimals? Write them just like, in this case, they line up anyway, but okay, let's do it this way. Let's say this is just 5.3. Only, but if I lined up my decimal, I'm adding a 0 and I'm having to make a whole line of partial product that I don't need. So we only line up our decimals when we add and subtract. When we multiply and divide, we don't have to line up the decimals. Instead, what do? We keep their place, but we have to figure out what. Yes. I always like to just go ahead and look at the problem and I count how many digits do I have behind a decimal in the first one, and yes, total. So I have 2 numbers behind the decimal in the first one more behind in the second factor. So I have a total of 3 digits that are behind the decimal in my total factors. Also, one of them is negative, therefore my answer is going to be negative. So just don't forget to bring that down. Otherwise, ignore it. So now it's just multiply as usual. Just kind of ignore the decimals and do your multiplication. 3 times 8 is 24. Carry my 2, that becomes an 8. No carry. 5 times 8 is 40. Carry my 4, that's a 14. Carry my 1, 21. I'm going to annex in a 0. 4, 8, 6, 2, and 2. Where does my decimal go? The second. Between the 2 and the 6. Yes. And there's my answer. Good deal. All right, let's do it with fractions. So again, here's our. So let's look at multiplying. Put a little title on here, so find it maybe in your notes. Multiplying decimals. Now we're going to look at multiplying. Oh, sorry, that was negative, wasn't it? I forgot to tell me. We forgot to bring our negative down. Because remember the 4.228 was negative. Dun, 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 huh? Well, yeah, because I just added it to my product, my answer. Okay, multiplying fractions. Negative 3/4 times negative, I'm going to say 8/7. First off, is our answer negative or positive? It's positive because we have how many negative signs? Two, which is an even number. So this is going to be positive. So just would ignore those negatives. Now, what do I do when I'm multiplying fractions? Do I have to have a common denominator? Absolutely no. We can reduce. Cross multiply has an equal sign between it. But we can reduce. What can we reduce? The 4 becomes a 1, the 8 becomes a 2. Yes, this is much lovelier. So we have 3 over 1 times, 2 over 7. And that becomes 6. Easy enough? We remember all this? What if they are mixed numbers? Dun, dun, dun.
Oh, you add the numbers of
You absolutely, if it is a mixed number, you must change the mixed number to what we call it? To an M, it's N, sorry, N proper, M. Golly, improper fraction. Okay, 5 times, and so we do that by, we multiply the denominator times the whole number, and then we add the numerator to it. So this is 10 plus 11 gives us 11 over 5. 30 over 7. Dun, dun, dun. Oh no. What do we do? Reduce if the 5 becomes 1, the 30 becomes 6. And now we just multiply. We have, I shouldn't be using that x. I just said to not do it. It's 66. Just leave it like that. Unless it tells you to convert it back into a mixed number, don't worry about it. You may. You may. All right. We need to talk about something very important. All right. A unit multiplier is a fraction with two different expressions for the same quantity in the numerator and the denominator. Does that make sense to everybody? Right? I don't even know what I just said. Okay? Like, what do they mean? What are we talking about? The same expression or different, see, this already started. Two different expressions for the same quantity. Okay, this is what we're talking about here. It's a 1-to-1 ratio. So we use this with measurements of things. So give me another way that I could write or represent a length of 1 foot. 12 inches. Now, is the length of 1 foot and the length of 12 inches the exact same length? So that's what I mean by it's like a 1-to-1 ratio. Is that the same thing as 12 inches over 1 foot? Yes. So you can switch. It's like writing 1 over 1. What's the value of 1 over 1? What's the value of 100 over 100? Exactly. Right. So anything that if the numerator and the denominator, so yes, these don't have the same numbers, but because of the units, the feet and the inches, they are representing the exact same length. It's a 1-to-1 ratio. So you can alternate it. We could do the same thing with if I had like 2 cups to 1 pint. That's the same as 1 pint, 2 cups. Okay. So these are called unit multipliers. So these are important when I tell you, when you have a question like, so let's have an example. How how many feet are this is going to be bad English. How many feet are 60 inches? How'd you get that? So you start with what they give you. So pretty much, so I would say like 60 inches represents how many feet. It's probably a better way to write this. But you start with what you're given. We're given 60 inches. I'm going to write that as a fraction. I'm going to put it over 1. Any number over 1 is just a self. And I'm going to multiply it times its unit multiplier. Now, what unit do I want my answer to be in? Feet. So when we reduce or cancel, we cancel from numerator to denominator. So how would I write my unit multiplier for inches to feet? Would I write it as 12 inches over 1 foot? Or would I write it as 1 foot over 12 inches? Well, let's see. Let's try it the first way. If I write it as 12 inches over 1 foot, can I cancel my units out? No, because you have to cancel from numerator to denominator. Now, let's do the math. Let's say you just figured this was it what's 60 times 12? 720. Are your units in feet? No, your units are in inches squared over feet. Like cancel out your units just like you would numbers. So we know that 60 inches is in feet is not 720. So we have to flip it. 1 foot over 12 inches. Now can I cancel out the inches? My units. So now I can cancel. If you treat them like a number, they cancel each other out. Do we want to reduce some more? You can your number, right? 12 and 60. 12 goes into 65 times. I mean, if you didn't, you'd end up with a fraction. You'd reduce it then. So we have 5, not F, 5 over 1 times 1 foot over 1. We've canceled our inches. And so we end up with just 5 times 1 with a unit of feet. And we have our answer. 5 feet. Let's do let's see if I've got an example here. Yeah. Let's do the homework as an example. I feel like this is where are you? 1 through 41 odd. But we're going to start with the kind of the conversion part. So you have it. Surprisingly enough, this is less than what they gave you. And I was pretty confident we would be able to get a lot of it done in class. So you should not end up with more than, maybe 10 or 12 problems to try on your own. All right, let's start 41, 39. Yeah, let's go backwards again. So 41 is like actually kind of easy and silly. So they want you to write 8 times -3 using the definition of multiplication as repeated addition. Literally, how many times? So the answer they're looking for is -3 plus -3. There's 3 times. Seven. Aren't you glad we have multiplication?
Oh, it's not that big of a deal.
Well, yeah. That's what they want us to write.
That's the problem. It's not.
They want us to write 8 times -3 using the definition of multiplication. So this problem is simply to encourage you to appreciate the expediency of multiplication and the fact that you don't have to take up quite so much room or give your finger cramps. There's a, because it's literally -3 plus a sub 8 times. 39. I would say. So for 39, find the pattern in each series of statements and express it as a general property using a variable. All right, this is not anything that we really talked about in this section, so that's why I wanted to do it together. All right, so write down what they give us first. -3 equals -1 times 3. -4 equals -1 times 4. 7 equals -1 times 7. So they're wanting us to write it as a property. So what pattern is this example showing us? Why are they negative?
Because they're each being
Being what?
the ones.
Not just one. Negative. So you're saying for any number, so the negative of any number equals -1 times that number. What do you want to use to represent any number? So our property here is -x equals times x. It's teaching you to represent. So you're telling me you just created a rule that a negative number equals -1 times that number. Does that work? Would that work for any number? No? Okay. As long as x does not equal 0. Sure. Fair play. Okay, now this is an example of the conversions we were talking about. 37. Convert 13 inches to centimeters. And they've given us the conversion. 38, yeah, I almost started doing that as well. 1 inch, this is actually approximate, but we'll take it, is approximately 2.54 centimeters. Oh, learn the conversions. All right, so what do I start with, Zach? Are we 37? How do you know you're multiplying? So I don't want the whole problem. What do we start with? You always start with what you're given. You're given 13 inches. Set it as a fraction. What is my unit multiplier? over 1 inch. So when we write it this way, do we cancel our inches and we're left with only centimeters? Yes. So in this case, yes, we multiply, I did that, 13 times 2.54. And we're going to have our answer in centimeters. Now, if I had centimeters and was told to convert them to inches, I would have had to divide by 2.54. That's why you write it this way. Because if I had 13 centimeters and was asked to convert it to inches, I would have to write 1 inch over 2.54 centimeters. And you see how when I do that, my centimeters cancel? That's why you write it this way. Just in case you confuse whether you multiply or divide. So, because that's not the choice for that. But in this case, yes, you would divide 13 by 2.54. But we don't, because we're going from larger to smaller, so we're going to multiply. And your answer, you already have it, 33.02. Sure. So 33 and 200 centimeter is our answer there. All right, let's try 35. So 35, we're going from feet to yards. So do you think we multiply or divide? When you go from smaller to larger units, you divide. When you go from larger units to smaller, you multiply. But if you write it the way I've shown you with the unit multiplier, you'll see which way you go. 88.2 feet over 1. And then what is my unit multiplier, feet to yards? How many feet are in a yard? Yeah, 30. What about that? The inch thing, right? So how would I write that though? Do I write, if you do 3 over 1, what's that make your units? 3 feet over 1 yard.
Oh, okay, so
There we go. Because when you look at this, you can't cross out feet. You're actually going to have feet squared. Then we want to write this the other way. 1 yard over 3 feet. Again, this is just 1 to 1. We can flip it however we want because they're both the same length. So this will cancel out the feet and allow us to get our answer in yards. So I ended up with 29.4, and just go ahead and do the math. 3 into 88.2, my decimal there. 3 goes into 8 2 times. That gives me a 6. Bring down my 8. That's 9, which is 20, not a 3, 27. 1, bring down my 2, and 3 goes into 12 4 times. We end up with 29.4 yards. Okay? And then a squeezy. 33. Mike, Melissa, and Matt each pick 2/5 a gallon of strawberries. How many gallons of strawberries did they pick altogether? Looks like our answer is in gallons. So this is no more conversions. This is a word problem. So how many gallons of strawberries did Mike pick? 2/5. How many did Melissa pick? And how many did Matt pick?
3.
So it's 3. There you go. 3 times what? 2/5. Now you can do it this 2 ways. You can put that 3 over 1 and then multiply, or you could just leave it that way. You know that you're multiplying 3 times the numerator. And so that's giving you 6/5. Now, we are talking about gallons here. Is that more than a gallon or less than a gallon? It's more than a gallon. Why? Yep, the numerator is larger than the denominator. So because we're talking about gallons, nobody says 6/5 of a gallon. So we would just say 1 1/5 gallons. All right. Y'all still have 5 minutes, so work on numbers 1 through 31, odd only. And we'll check those tomorrow for your homework grade.